Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, number of good components. So we'll be given an undirected graph with V vertices and E edges. We need to find the number of good components in the graph. Okay, a component of the graph is good if and only if the component is fully connected. A fully connected component is a subgraph of a given graph such that there's an edge between every pair of vertices in the component. The given graph can be disconnected graph. Okay. So what they're saying is, let's go through this example. What they're saying is the given graph, the complete given graph can be a disconnected graph, right? So here if you see, there's a disconnected graph. So here there's no connection between 1 to 4, right? There's no connection between 1 to 4. So there are three subgraphs if you see. 1, 2, and 3, right? In this given graph. So what we have to do is, we want to find out the number of good components in this complete given graph. So what are the good components? Let's see in this case, right? So here, this is the good component. 1. Why does it good component? What is a good component basically? So if there are, for example, let's say 3 edges, right? So a good component is a component wherein there's an edge between every pair of between every pair of vertices. Okay. So here if you see, that is each vertex is directly connected to every other vertex. Okay, every other vertex. So this is a good component, right? So okay, so here is a case. So that is why this is the good component, and another one is this one also. Being a single node, so it is going to be a good component. So there are two good components here. Okay. So there are two good components in this given graph. Okay. Now, how to find out, like, what? Let's see if there is any pattern to find out a good component. Okay. So for example, if we consider this, right? So for three vertices, how many edges are there? 1, 2, and 3, right? So here there are 3 edges. In case of, let's see, in case of four vertex, for example, can we find out some pattern here? Okay. Here, for 4 vertex to be a good component, so how will the graph look like? To look like something like this, right? So for 4 vertex, how many edges are there? In the if it is a good component, 1, 2, 3, 4, 5, and 6. So there are 6 edges. There will be 6 edges. Let's see in case of 5 number of vertices. Okay. So how it is going to look like if it is a good component? Something like this. Right? This will be connected to this, and this will be connected to this directly. Okay. So every vertex is directly connected to every other vertex. So how many vertices are 5? How many edges? 1, 2, sorry, 2, 3, 4, 5. Then inside what edges? 6, 7, 8, 9, and 10. So there are 10 edges. Okay. So there are 10 edges. So if you see, is there some formula here? So if you see the formula, right? E equal to, it is something like, see, V into V minus 1 by 2. If you see here, right? So V, what is V? V is 3 into V minus 1, 2 by 2. Okay. So it is 3. Yes. So it is 3. See, edge is 3 here. For edge is 3. Now in this case, right? What are the number of vertices? E equal to 4 into 4, V minus 1. V minus 1 is 3 by 2, right? So 6. So here we are getting 6, right? Similarly, if you see, we'll get this as well. So what is the formula here? E equal to V into V minus 1 by 2. It is nothing but NC2. That is, for example, number of vertices V, right? So VC2. Okay, combination. So this is a formula. Okay. Now what we're going to do? Now, in order to calculate the number of edges, right? In order to calculate the number of edges and count the number of vertices in the given subgraph, okay, we are going to use DFS, okay, to traverse the graph. Okay. Now, in the DFS, right? In the DFS, and as it is going to be it is undirected graph, right? It is undirected graph. So there are no arrows, right? There are no directed. It's like the edges are undirected basically. So in this case, for example, if this is the pair, right? So 3 to 5 and 5 to 3. So it is going to be counted as two number of edges. Okay, two edges. One is 3 to 5 and another one is 5 to 3. So here our formula is going to be change because the count, right, between each pair of vertex, it is going to be twice, 2, right? So the formula is slightly going to be modified. The 2 will go here, right? Okay. So the edges is going to be 2 into E, for example, V into V minus 1. So this is going to be the formula. Okay. In order to calculate, right? In order to match, right? The number of, so this is going to be the actual count and this is going to be the expected, right? So it is going to be, the formula is going to be V into V minus 1. Okay. So let's see. I'll start the coding. Before going to the code, I would request you to subscribe to my channel. Thank you so much. Okay. So for example, let's now I equal to 1, I less than equal to V, right? So we are going to traverse each vertex, right? And also we are going to have a Boolean visited array V plus 1 because the vertices are starting from 1, right? That is why we have to take v plus 1. Now what are we going to check? If a certain vertex it is not visited, then we are going to run DFS on that. DFS, standard DFS. Okay. So what are we going to pass? We are going to pass this I as a vertex, then this visited Boolean array, and another would be an adjacency list. So we need to create an adjacency list. So this we have edges, right? Set of edges. So from this set of edges, we have to calculate the adjacency list. So what it is going to be? List. So I'm going to first write the Java code followed by C++. Okay. So just be with me. And we want to have the number of this. Okay. Right. So what we're going to do? Add adjacency dot add. Okay. Sorry. Yeah. First of all, we'll have to new array list. With this, then what we need to do? For in edge edges. So out of edges, we are computing the adjacency list. Okay. So what it is going to be? So as it is going to be a pair of edges, we have to convert it into list. So get edge of 0 and add edge of 1 to it, right? As it is going to be an undirected graph, so we want to do the reverse as well, 1 and 0. So we have computed the adjacency list here. So we are going to pass this adjacency list, right? Now what we are going to run? We are going to run a simple DFS as it is static void DFS, right? Int v boolean visited array and this list we want, right? So what the standard practice is, first what we do is we mark this as true, that is visited. Then what we do, we traverse the neighbors of this visited vertex in br, right? Adjacency dot get v. Then what we're going to do, we are going to check here again. If it is not visited, then only we'll run DFS again on that neighbor and br, right? So run DFS again, DFS with neighbor visited and adjacency list, right? So this is a standard DFS algorithm. Okay. Now what we want to do here is we want to calculate the number of vertices and edges also. Vertices in case of subgraphs, right? So let's have global variable in place, vcnt, that is vertex count, and for edge count, we have two variables, right? Okay. So what we're going to do is we are going to calculate here vcnt. It's going to be straightforward. We are going to increment, right? For every unvisited node or vertex, right? And what will be the formula for e count will be adjacency dot get v dot size. Why this? Because for let's see now what is going to, how will the adjacency list look like, right? For example, in case of this graph, right? How will the adjacency list look like? 3, for example, 3, 4, and 5, right? So what will be the edges here? If there are edges from 3, right? So 3 to 5, right? 3, 4 to 5, right? So if there are edges 2, 4, and 5 from 3, right? So how it is going to look like? It is going to look like this, right? 4, 3, and 5. 5, 3, and 4. So what we want to do? We want to, this is the adjacency list, right? So we are going to have this size, that is 2, right? 2. So hence we are doing this. Adjacency dot get v dot size. So v is 3, for example, and what is the size? V is 3, for example. What is the size? Size is 2. Okay. So here it is. We have calculated the e count as well. And simply what we're going to do, for every pair of vertex, right? We are going to set this as 0, right? For 0, initialize with 0. I'll tell you the reason for this. And then in the DFS, we are going to e count and v count are anyways is calculated, right? So we have post DFS, if it is not visited, we have the e count and v count. So what we're going to simply do, if it is e count equal to v count into v count minus 1. That means we have found our good component. So we'll also have an answer variable int answer, that is a count of number of good components. If such is the case, then let me increment the answer. And simply what we're going to do, we are going to return the answer. Okay. So here if you see why we are initializing 0 again, because of this, right? For example, if we start with this, so we are going to start with 1, right? Right. So this is a subgraph. This is a subgraph which is not connected, right? Which is not connected with this one, right? Right. So when we start, we are going to have some h count and v count here. But when we start with this, right, with this subgraph, then we need to initialize v count and h count again to 0, because there can be subgraphs, lot of subgraphs, right? Many subgraphs. That is why with each vertex we are initializing this to 0. Okay. Okay. So here, let me run this now. Okay. Let me submit it. Yes, the solution seems to be accepted. Thanks for watching. Please subscribe to my channel if you have understood the solution. Let me also walk you through C++ code quickly. Okay, so here is C++ code. So here what we have here is we have adjacency, right, list here again. Okay, and then we are converting the edges to the adjacency list or vector, adjacency vector. Okay, then what we're doing, we are having a boolean array, that is visited array. Then we are iterating through every vertex. We are having recount, count as 0. And if you're checking if that is not visited, so let's visit that. Let's run DFS if that vertex is not visited. And then we are checking for the formula. If it matches, then increment the answer and return. Let's quickly walk through this DFS as well. We are marking as a first, we are marking as a vertex is visited. Then we are incrementing the V count, E count, right? And we are iterating to the neighbor. If that neighbor is unvisited, we are running DFS on that. So this is a code. I hope you've got the code. Uh, please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much, everyone.